Children, uh, good afternoon. Still we can see only 4 students here. For today, environmental management and cleaner production. We have Medmita, Afam, and one IM student. Yeah. Anyway, we will continue the session. Okay, we will continue the session. Today, my notebook. I have little issues in the notebook, the typing, some technical issues, but let me try. Let me try to develop the same way the notes together with you. Notes together with you of one of the very important area. Okay. Let me see. Today, yes, so that's why this has little issues. Don't worry. Have you heard the word heat? Have you heard the word work? Have you heard the word energy? Have you heard the work? Environment. And also clean energy and also renewable energy. Okay, here a noise, huh? What's a noise? I'm using the on-screen keyboard because my keyboard has some issues computer. Renewable energy. Cleaner production. Cleaner production. Cleaner production. Sustainability. 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 Cleaner production, sustainability, and even economy. Economy. No. Okay. Today I'm going to start somehow with a story. Okay. Somehow with the story. Let me save this file. Energy. Okay, energy. presentation. Energy presentation. Today is the environmental management and cleaner production. Okay. So very important topic because now we are ready to diversify the topics. Let me slowly come into these words. So before that, I'm asking from you, have you heard the word shale? Have you heard the word shale? Anybody? Have you heard the word shale? Shale kina vachana halatina. I think my spelling should be all right. Okay. Have you heard the word shale? Whoa. Have you heard the word shale? Whoa. Have you heard the word shale oil? Also, do you know or do you aware that in future there will not be that much of petroleum fuel prices increase? Petroleum fuel prices increase in the global market. There will not be. Why? Because of this shale. Because of the shale. Because of the shale. Of the shale. Because of the shale. There. Today my note the keyboard. I have to change the keyboard in Vidya. The future. Rising of global oil prices. Oil means this is petroleum, as you know. Huh? Petroleum oil prices is unlikely. Means very less chances are there to increase the world oil prices. One reason is the shale. The shale triggered this. The shale triggered this. Now there are many others. Okay? There are secondary facts as well. Did you know this? Okay? Did you know this? Did you know this? Yes. What is shale? What is shale? Yeah. Did you try to browse what shale means? Okay. What is shale? So I'm looking for one maybe I'm browsing here. What is shale? Yes, shale oil. Shale oil. Shale oil. Yes. So this is a new technology, but not to say new. This is bit maybe 2 decades old technology, but now producing petroleum from shale, we call it shale oil, now looks economical. Huh? They are using this oil shale rock fragments. Oil shale rock fragments. Yeah. So I will get this from Wikipedia here for the convenience. Let's say, so this is not what I say, but the world says maybe. Let me talk about shale oil. Shale oil, too small. Shale oil is an unconventional oil, means a non-standard, that is not from the, you are taking from the below ground level, and those are not in the liquid form. This is unconventional oil, means the processing of oil is totally different, produced from oil shale rock fragments. You go for the oil shale rock fragments, then you then these fragments are subjected to pyrolysis, hydrogenation, or thermal dissolution. This is the process. So these processes convert the organic matter within the rock into synthetic oil and gas. This is a new technology. US really explored this shale oil technology. The main reason is the Middle East is really controlling the world oil stakes, and they are controlling the prices. So in order to get rid of that burden or that concern, US first started producing this synthetic oil and gas from the shale oil rock fragments. Yeah. Very interesting, this one. So once US started this producing of shale oil, US demand for the Middle East oil drops. The Middle East, the biggest customer was US. So when they start producing shale oil, they don't want anymore to buy excessive oil from the Middle East, means the Saudi Arabia and all the Middle East countries. So that's how the demand for shale oil dropped. And even for the Venezuela, Venezuela is a communist country, US is the other way. So they are rivals. And because of this shale oil, one started producing in US. Venezuela country went into bankruptcy. Even now, in future, the Middle East countries, their economy may not be that rosy unless they go for diversified economic ventures. That's why now you can see Middle East, they are going for manufacturing, education as a business, and somehow they are diversifying. Even airlines, you can see in the Middle East now, they have the Emirates, and Qatar Airways, Oman, and they are very good in the airline industry also now. Or even in education, you can see Emirates, Qatar, even Saudi Arabia, they are coming up now. They are really outsourcing the academic talents and all, and they are really building their foundations for universities and all the academics feel as a business. Yeah. So they are also diversifying because one day the Middle East will be out of business. Not to say out of business, they will be poor really. Once they are, how to say, the dollar reserves are depleted. They have a lot of dollar reserves because they have earned a lot, but now time is running out for them just because of shale oil. So let me talk about this. It is okay to learn this. Huh? Yeah. So that is shale oil. You can read where the shale deposits are very interesting. You can see shale deposits. You can see shale deposits. You can see shale deposits. In many of the parts of the world, mainly US, there are plenty of shale oil, the shale rocks. Russia, they have shale rocks because Russia is really rich of natural resources. Indonesia, they have shale rocks a lot. You see the world map for shale reserves. You will see this, even we will explore this. Even China, they have shale. Yeah, that's why. So everywhere now the shale energy is coming. And not only that, the other types of energy like the renewable energies, that's why I mentioned the renewable energy there, like solar, wind, even the nuclear, those are coming. Okay, so the good clean energy resources are coming now and getting popularized, and they are becoming more economically feasible. So that's how the energy landscape is changing. That's why in future there are no more energy wars. Yeah, earlier people battled for energy. That's why US has geopolitical interest on Middle East. Even Russia had geopolitical interest, but now they all abandon Middle East. Yeah, of course they are doing projects. That's all. But anyway, oil is no more of interest for the others. Middle East oil. That's why. So don't expect future rising of the petroleum. That is very unlikely. It is dropping day by day. There may be only little fluctuations. You believe me. So that's about the shale oil. I believe you are reading it. So let me look into some. What happens? The shale, when start producing shale oil, the OPEC countries, even they brought their petroleum oil prices down. Yeah, so you can see the shale war. This is really about the pricing and the resources. History of the shale. US shale will be first. Yeah, anyway, the of oil price war, because the Middle East, they have started bringing the petroleum fuel prices down to stop US producing shale. But anyway, things will come to a balance and no more increase of the oil prices. It is like that. Okay. See here, news, you can see a lot of news are here. This is about shale, the oil price war. The shale is really an innovation. It's a real energy solution as an alternative to these petroleum prices, and it worked. It worked. Yeah. So that is about the shale story, even the shale war. You can see the articles, what's happening in the world. Shale war, the price war was really there maybe 8 to 10 years back. There was really some world articles you can see, but I don't know why my keyboard is not working, it seems. Yeah. CNN, you can see some news also about the shale war. Yeah. So this is Oil industry. Shale is something really made the industry landscape changed. Yeah, I see one chat here. Oh, can't hear clearly. 216. Can't hear clearly. What's that? Sorry, but I cannot hear clearly means. Let me switch off the fan and see. I believe now it will be more silent. Yeah. Mm. So that is about the shale. Okay, that is about the shale. So let me go back to you. You can later look into this. Okay. So if I go to this first slide, if I go to this first slide, so heat, work, energy. This is our today focus, but it is important to learn about this as well. What is happening there? Okay, so shale is not renewable. Shale energy is not renewable, but one day this will be depleted. But there are plenty of shale resources in the world. Okay, shale resources in the world, shale oil resources worldwide. If you see the maps, perhaps this map may be right. Yeah, this is all about the shale reserves. I got this from internet. Anyway, oil shale reserves may not be that, or maybe. It's very difficult to say unless I really look into this. This may be more reasonable. Let me take this out. If I paste this, shale. Yeah, somehow you can see some global resources of shale. Russia, China, Indonesia, you have even US, Canada, Latin America, even in African continent, you can see the shale oil even in Scandinavia. So those are the already identified reserves. So there would be many more of this. Okay. So this is the shale map. Yeah. Basins with assessed shale oil and shale gas formations, the basins. So these are already the commercially viable shale deposits. Well by this. Okay. Well by this. Yeah. Anyway, it's a good story. Yeah? So this has some world economic issues are there because of this. Some countries went on bankruptcy, especially the Venezuela, if I'm not mistaken. That country becomes suddenly poor because their oil market dropped drastically. Yeah, see the situations. Yeah, so the oil brings a huge revenue for Venezuela, but finally, because of the dropping of the market and the prices, the Venezuela, the income become much more lesser than their expenditures. And as a result, because of this negative negative economy. It prolonged for years and years, and countries facing a lot of troubles because of that. But now they may be managing somehow, but it's no more that uh, economically attractive for oil markets. Yeah, so that's the issue. Yeah, even for Russia, this is a big issue in future because of the shale resources. Yeah, so that's about the shale story. Enough. The shale story is enough. And let me look into the environmental aspects of our main slide. Okay, yeah. Heat, work, energy, environment, clean energy, and all. So far, including, okay, shale, including shale, petroleum and shale, all including, those are not that eco-friendly energy resources. Petroleum and shale are posing equal threats, okay, are posing equal threats to the environment, equal threats. Some issues here. To the environment and human health. Human health. Because when you burn those energy, when you burn those, the emissions, because when burned, CO2 emissions, CO2 emissions. Oh, sorry. Emissions. CO2 causes global warming. So the sulfur oxides and dioxides we call SOx NOx, okay, SOx, NOx, and also when you use to produce energy, these oils, you have to burn this, and even heat losses, okay, heat losses. So all are risks to the environment and human health. And particulate matters, I believe you have learned about particulate matters, PM 2.5 and all. Yeah, PM, okay, or particulate matter, PM 2.5 and PM 10. You know that in Norachole area, the houses there, the people are living, they are experiencing lot of fine dusts. Even the sky is not that clear. Okay, the emissions. That's why. So when it comes to this petroleum based, because when you need to generate energy out of petroleum, you have to burn those. Yeah. Once you burn, CO2 emissions, okay, leading to greenhouse effects, means for global warming and climate change. And SOx and NOx leading to acid rains or makes the water acidic, and also heat losses to the environment. Also, it makes the environment bit heaty. And the generation of particulate matters, and just going to the the space there, and then normally flow with the winds and finally settle down in even in miles away on the people's houses and all, and that makes another health risk. So those are the issues. So it is very important in many ways. You should and we should minimize the usage of this petroleum based energy. So that is the issue. So minimizing means most of the time, minimizing one way is efficient use. Okay, efficient use. That is very important. Efficient use. There can be other strategies. Alternative energy uses. Alternative. Instead of petroleum, we can go for alternative. Sources. Alternative as a replacement sources of energy. Alternative energy sources. Okay. I have an issue today. Not only today, even yesterday I have experienced this. Alternative energy. Instead of petroleum, you can go for solar. You can go for wind. You can go for hydro, even mini hydro. Solar, wind, hydro, then even nuclear. I will put it here because if safely used, nuclear is a clean energy. Clear? So let me put nuclear at last. Solar, wind, hydro, geothermal. Okay, geothermal. Geothermal means underground. Yeah, they are very hot water or maybe heat there, so we can tap the underground heat, geothermal. Somehow, geothermal, interesting. Tidal power. Tidal power means tapping the energy from the waves in the sea. Tidal power, or tidal energy. So solar, wind, hydro, geothermal, tidal power, nuclear, etc. So this is one of the important things. Alternative use of energy, alternative sources you use. Solar, just fix a panel, you will get it. Wind, just fix a windmill. Anyway, windmills should be wind farms, windmills, yeah, you will get it. Hydro, you can run the turbines, hydroelectric, the turbine and generators, hydroelectric power generation, geothermal, tidal power, nuclear, and that's why when it comes to that kind of solutions, technologies, and the technology applications are very important, okay? And also efficient use is very important as well, okay? Yeah. So today, anyway, this is not a simple uh, topic. This is quite complicated, quite serious, quite important topic, okay? And we will see, anyway, we have to say this as a background to look into further what we can do in our subject, I mean, the environmental management and cleanup production point of view, what we can do in terms of uh, alternative source of energy usage and also the efficient use. Yeah. Those are very important, okay? Yeah. So today about this. Yeah. So just because of the threats posing to environment and human health from petroleum and shale, you imagine nowadays, because of the corona, we all experience that we have less issues in respiratory sicknesses during the non-corona, early, the pre-corona time. Many are coughing if you get into a bus. Even you can notice that many are coughing, even on the roads, even in the classrooms, coughing. But now, very hardly you may remember the coughing instance. Yeah, that's why. So the respiratory illness are no more there because PM, particulate matters, are less emitting. CO2 emissions become lesser, SOx, NOx less. That's why, but now again the more vehicle traffic is high. So the vehicles, most of the vehicles, they are using this petroleum. And even in US, they may be using even shale now. Yeah. So again, this pollution is coming back. Yeah. Pollution is coming back. The reason is you need energy because the vehicle needs energy. To have the electricity, you have to run the generators. It needs energy to drive the generators. And the primary source of energy happen to be petroleum based, either diesel, most likely the diesel, heavy diesel, furnace oils and all. So those petroleum fuels, one starts burning to produce energy. So because you have to burn the petroleum, then only you can get energy. Yeah. If you buy petrol from the petrol shed, you just keep it wherever it won't work. To make use of that energy, you have to burn petroleum fuel. In the vehicle, engine inside, you are burning petroleum. Okay? In your gas cooker, you are burning petroleum natural gas. You have to burn it. In the power plants, you have to burn the fuel, either coal or diesel, whatever, you have to burn it. Yeah, that is the way the petroleum generates energy. That's the way the petroleum sources generate the energy to get other things done. Yeah. It needs simply burning. Burning produces emissions other than the energy needed. That is the issue. So petroleum burning is not a good energy solution. It's not a good energy solution at all. So that's the issue now. Well, so let me duplicate this slide. Yes, you have to listen today really what I'm telling. You have to listen today. So in the industries, when it comes to petroleum and shale, we are not receiving shale oil anyway. So in our case, for Sri Lankan context, Sri Lanka, no shale. Petroleum posing threats. Yes, that is obvious. To the environment and human health. No one can deny this. Yeah. And the strokes and all, some cancers, heart diseases, all mainly because of the air pollution. This air pollution not coming from your kitchen, or it's not coming from your garden, or it's not coming from the jungle, it's coming from burning petroleum fuel. Yeah. So when burnt, CO2, sulfur oxides, nitrous oxides, heat losses, and particulate matter, all coming out. So this is the Sri Lanka issue. Yeah. So now, because of this, if we have no choice, if you have no alternatives, you have to use efficiently. Efficient use of energy is important. The other is the alternative source of energy can be used. This is the other solution. Okay, so this is the other solutions. Yeah. So let me look into the efficient use. Okay, the efficient use. Let's say now I'm going to look into this. You have no choice. You are burning petroleum. Okay, and emissions are there. So now what we are going to do is, and later we can talk about the alternative. Now we are looking into efficient use. Okay, you are looking into efficient use. This alternative use, I will just put this aside. Okay, later we will think. So the strategy is quite straightforward. Either efficient use or use alternative energy source. It's very simple. Or else we have to get changed. Get changed. Get changed. Maybe our lifestyles, yeah, we have to get changed. Maybe lifestyles, you are doing more like, let's say, example, instead of traveling, now we are using online, so the traveling costs and also the resources, petrol and all, consumption is no more there. So that's how we get changed. Yeah. And also innovations. Yeah. Innovations. Instead of using the petroleum-based energies to get work done to do something else, now you are looking for innovative solutions. Yeah, innovative solutions. Innovative solutions to avoid what? Give you idea, avoid. Avoid avoid using of petroleum energy, petroleum resources, using of petroleum resources. Sorry. Using of petroleum resources. So that's how. Innovative solutions to avoid or to reduce. Okay, to avoid or reduce. To avoid or reduce using of petroleum resources. Okay, so these are the three things: efficient use, alternative source of energy usages, of energy usage. Or else get changed or look for innovative solutions to avoid and reduce use of petroleum resources. So these are very, very important. Okay. So these are the things we have to do. Yeah. So you know petroleum, we have to burn it. That's it. So to avoid that, innovative solutions, we have to get changed our lifestyles and whatever would benefit. Or alternative sources we can use. Or efficient use. Okay? Efficient use. Yeah. So are you ready for this? Are you ready? How do you feel about this? Yeah. How do you feel about this? Yeah. I believe you can see this slide. How do you feel about this? So not to say Sri Lanka, let's say at our home. Okay? At our home. At home. At home. Okay? Yes, I will take example. Okay? I will take example, efficient use. Again, I will take example. Let's say example, cooking. Rice cooking. I think the food students may be quite happy to see this. Rice cooking. Rice cooking. At home, rice cooking. So this is the case. Okay, case. This is the case. home, rice cooking. Okay. So this is about the energy. So let's say rice cooking. You may be using rice cooker, right? Rice cooker, electric rice cooker. Let's say I will clarify it. Little issue today. Electric. The keyboard is gone. Okay. Rice cooker. So I'm typing it on screen. Electric rice cooker. Okay. So you are using what? Electricity. Okay, electricity. Is it clean? Of course. Electricity. Okay, electricity. Yes, good. But if this electricity comes from Noracholi, what's the issue there? Noracholi. Coal power. Then what happens? If this coming from Noracholi coal power plant, okay, let's say Noracholi coal power plant, what happens? So is your using of electricity okay? How do you feel? Okay for your home, but indirectly you are polluting. Indirectly you are contributing for pollution. Yeah. So then what happens is you are indirectly contributing for pollutions. Yes, that's the point. Indirectly contributing. This may be okay because you are somehow we have plenty of rain maybe. Noracholi may not be that functioning, but who knows when the drought comes. That's why you need the efficient use at least is very important. That's why efficient use is important. Or else we have to look for alternative. If you can look into maybe solar cooker for this rice cooking issue. So this may be solar cooker you can use. Let's say solar cooker. solar, rice cooker. Yeah, maybe in the market. If not in the market, you try to do one. Solar rice cooker. Yes, food students, even the innovations, the management students, even manufacturing, you can look into this. Yeah. Okay, you can look into this alternative source of energy. Okay, alternative source of energy. So rice cooker, that is the solution for you. Also, that can be an innovative solution as well. Yeah. So solar rice cooker. Or else, even you can get change maybe. Even you can look for the innovative rice cooking. Technology-wise, rice cooking is what we say, maybe mechanical, manufacturing, IM students, we are seeing rice cooking, but when it comes to food, for them it's a matter of molecules and chemistry, you know. For food technology students, this is molecules and food chemistry maybe. So there may be other ways and means of getting the rice, something like cooked, something like cooked. Yeah. So getting rice, something like cooked. Maybe you are using different techniques, different technologies. Yeah. Who know? Low temperature cooking. Yeah, possible. Possible. Low temperature cooking possible. Cold cooking, who knows? Possible. Yeah. So some innovative, different cooking techniques. Cooking techniques. That's why these are the points for innovations. Cooking techniques. Or maybe you can use, there may be some good rice. Maybe there is a fast cooking, but still preserve the good quality and all. Maybe it needs less water or whatever. The different varieties of rice, rice varieties, rice varieties, rice varieties. Possible. Yeah. So that's how you have to look into the approaches. You have to look into the approaches. Okay, you have to look into the approaches. That is very important. So now you know, even though you are using an electric rice cooker, you are using energy from Norochan, you are indirectly contributing for pollutions. But anyway, this happens to be the lifestyle for everyone. So that's why the government, they should know that instead of Norachole like power solutions or energy solutions, they should provide clean energy solutions for the nation. That's why we have no choice. Whatever the electricity available, no matter the primary source, we are using electricity. So the governments, they have the responsibility to provide the clean energy source. That is very important. Yeah, that is very important. But we have some responsibilities. Efficient use. Now we are going to talk about this. So alternative sources. Solar rice, solar cookbox. There are solar cookbox. You can use it. Yeah. Even you can get the solar. Somehow you can get the solar concentrated. Yeah. Or even you can use the solar panels. Electricity from solar panels you are cooking at home. Yes. Solar rice cookers or solar panel electricity. Solar panel electricity. hydropower electricity. Yeah. So those are the things you can look into. Solar, rice cooker, solar panel electricity for cooking. For cooking. Very interesting. That's why. So when we think of this, uh, it gives some benefits as well. Solar panel electricity for cooking. You are not paying for the electricity for the meter. You have free maybe one installed solar panel. Solar rice cooker. Maybe once you buy the solar rice cooker, you are not paying anything. Only the, of course, you have to spend for the rice cooker. That's all. After that, free energy solar. Maybe not every day. You cannot use nighttime cooking for solar rice cooker, but daytime, just one time cooking will do. Yeah, maybe. Yeah. Oh, you have to get change. Solar rice cooker with get change. Yeah. Innovative solutions to avoid and reduce using of petroleum. Yeah. So those are very good. So for the Sri Lanka case, cooking techniques, rice varieties. I think food students should know this. Yeah. Food students should know this. Yeah. So those are the things to look into. And our focus now is mainly with the existing petroleum usage. We will see how we can look into the efficient use. Even alternative nuclear, whatever efficient use is important. So let's say efficient use. Efficient use. So this is the point. Efficient use. Efficient use. Efficient use. Let's say now I'm going to draw this. This is the cooking process. Okay. Cooking process. Sorry, I think next time I will try to resolve this. Cooking process. So this one is cooking process. This is cooking process. Yeah. So you are receiving, this cooking process receives energy. Okay, this cooking process receives energy. That's why energy, maybe heat energy. From the electricity, you are converting this energy in. Okay, the process is taken place, and after that, your output is the cooked rice is out. Okay, so this is your output. Okay, and also there is something energy loss. Okay, yeah, that's why I'm slowly coming into some and energy in. Okay, we call it Q in. Okay, Q in, energy in. Even in a rice cooker, you know that if you touch outside of the cooker, it is hot. There should be heat losses. So Q means heat. Q means so. When you have Q loss here, and this is your heat in Q in, so the effective use of energy for cooking process is Q in minus Q loss, effectively used. Q in minus Q loss, effectively used. So Q in minus Q loss. So this is what we call the Q net. The net use. This is Q net. So this is the effective use. Effective use is Q net. So you can notice this. Okay. So this is the effective use, Q net. So Q net is used here in rice cooking. This is the effective use. Q net, okay, is the effective use. Okay, now you can see that your input is Q in. Your effective use is Q net. So loss is Q in minus Q net is loss. Okay. So if I write this, sorry, if I write this again in a different way, Q loss is one way, Q in minus Q net. Okay, this is your Q loss. So here comes out is cooked rice. Okay, cooked rice. So your Q loss is this. Okay, and what's coming out is cooked rice. Okay, cooked rice. Cooked rice is here, and for this rice cooking, only required is Q net. You have certain pressure and temperatures for that specific uh, amount of rice and for that specific variety. So this may be a rice cooker. So Q is the heat. Q means heat. So Q means heat today. I'm really suffering because of this. That's why. So the heat is denoted by Q here. Okay. Heat is denoted by Q. So this is the notation. Okay. Heat notation is Q. Okay. Heat notation is Q. It's a notation only. So heat in means Q in. Heat loss means Q loss. So Q net means this is the useful net to Q use. Q net means Q use. Okay. Q use is Q net. Okay, that is Q in minus Q loss. So that Q is needed for cooked rice. So for cooking rice, that Q use is the needed one. Q needed. Okay, Q needed. No matter Qn excessively high. If excessively high Q in, there should be excessively high Q loss. You have the fixed Q net. That is what you need. Okay, that is what you need. So interesting. It is really interesting. Okay. See your energy use. So Q use is this. So it should be for the rice that is only the effective component. Okay. But there is no possibility to have zero Q loss is not possible. Okay, let me do this. Again, I duplicate this. It is not possible to have something like this. Okay, it is not possible. Yeah, so you have to have Q loss. There is a Q loss. That's how it is. There is a Q loss. Even a rice cooker, you know that the outside when you touch, it is warm. Even from the lid, there is a steam vent. Steam is going out. Yeah, so the heat losses are there. Even in the pressure cookers, the heat losses are there. somehow the warm rice means the other point. The rice can be warm. Actually, that is boiled, and that is above the consuming temperature. Rice is above the cooked rice, above the consuming rice temperature. Cooked rice temperature. Oh, cooked rice. Cooked rice. Too hot to eat. Too hot to eat. So you have to cool it. Again, some heat beams. Yeah. So if you can cook the rice just at the consuming temperature is very nice, but I don't know whether that kind of techniques are there. So up to food technology like people to explore this. Too hot to eat means this use is with rice. Too hot to eat means there is some excessive heat here, use, because the rice is energized now, cooked rice. See, the use is there. Okay, use is there. Yeah. So interesting, too hot to eat. So you have to let it cool. So certain heat again loss before consuming. So somehow Q loss is not possible to be zero. That is the point. That's the point. Not possible. Today I'm in real trouble. Not possible to be zero. Not possible to be zero. That's the point. Point. Q loss not possible to be zero. Q loss. Okay. Q loss not possible to be zero. Okay. So that is the point. Not possible to be zero. Very interesting. So somehow you have to learn this. Q loss not possible to be zero. So minimizing Q loss, there we need the technology. Okay. Even to have the clean energy usage QN, there you should need the technology. So this is a very good slide. So let me copy this. Are you there? All your 5 students are there. So here now we can write a kind of statement for how efficient, okay, how efficient this rice cooking is. How efficient this rice cooking is. That is very important. Okay. How efficient this rice cooking is. That is what we call the efficient use. So then there should be efficiency. So for efficient use, you have efficiency. What is the efficiency? Very interesting. Your effective heat against the input heat. Your effective heat. Q net. Okay. Q net. Q net. Okay. Divided by Q in. Against the input. Against the input. Your output. Okay, so this is what we call the efficiency to measure this efficient use, because we have to measure the extent of efficient use. That's what we call efficiency. Okay, Q net divided by Q in. Else you can write it as Q net is Q in minus Q loss. Oh, this is, let me see it this way, is the Q net, or else the other way is Q useful. Okay, that is Q useful. Q net means Q useful divided by your input heat, because for rice cooking you need to apply some heat. Okay, Q not by, so Q useful by heat. Or else you can write that as Q in minus Q loss. By Q in. Okay, Q in minus Q loss by Q in. So that is Q efficiency. That is Q efficiency. Further we can write one more here. This is equal to, because Q in by Q in is 1. 1 minus Q loss by Q in. So this is the word term for efficiency. And for the efficiency term, there is a notation, we call it neta. If you need a simple symbol here, let me look for the notation neta here. Neta. Yes. Yeah. Efficiency, we can use the symbol neta. Okay. Efficiency neta. Very nice. Okay. So this is your derivation for rice cooker. This is your derivation for rice cooker. Okay. Rice cooking. So you have the efficiency. So improving the efficiency, minimizing the losses, that is what we have to look into in manufacturing process. Even rice cooking is a manufacturing process. Okay. Even rice cooking is a manufacturing process. Interesting. Yes. I hope you can understand this. Okay, rice cooking for this case. Okay, so this is for a thermal system. I hope you can feel this well. Even for your car, okay, case, let's say car, or even iron, okay, ironing clothes. So now this is iron consuming this, okay, ironing process. Ironing. Okay. Ironing process. Ironing process. So this is the situation. Now you are using ironing clothes. So ironing clothes is the process. So ironing clothes process. So when you apply iron on the cloth get heated, okay, and certain heat is necessary for the clothes, not the excessive one. So you have Q net or Q useful, okay, and there is a loss, Q loss. So this is ironed. Ironed. Clothes. Yeah. Immediately too hot to wear. Okay. Immediate wearing too hot. You have to keep at a side to let it come at least to the body temperature. See, it's the same. Yeah. So efficient use. Yeah, that is very, very important. Okay. I hope you can understand this. So even for the exam, you can expect this. So today This is about some energy heat. So we are talking about heat mainly. Yeah. So duplicate this. Instead of ironing, now boiling water. Boiling water. So now boiling. This is the kettle maybe. Boiling. So boiled water. So with that water, of course, bring the water to 100 degrees. Very interesting. Too hot to drink. You have never noticed that. That's why for boiling you need it, but you have to let it cool. Too hot to drink at home. The process. Okay. Yeah. So again, there is some heat input. Maybe the burner from the gas cooker, or maybe a jug kettle, or a heater, whatever. There is a net use of heat, and always there is a loss. Yeah, so we have to minimize the loss. That is very important. Okay, Q loss. So Q loss not possible to be zero. That's the issue. So if we look into some case in industry, so let's say this is how to say. Let's say refrigerator. Okay, let's say refrigerator. Yes. So you know refrigerator consumes energy, electricity. So this is a refrigeration process, a cooling process. But here below room temperature, okay, cooling process. Okay, in. So somehow what happens is there is a Q loss. But this is different case, okay? Refrigerator process is different process. Okay. Let me not do refrigerator first. Let's see pasteurizing, heating process, heating, pasteurizing. Pasteurizing. It is the same, pasteurizing. Heating. Instead of pasteurizing, let me take sterilization. Sterilization. Sterilizing of food. Okay. So then it's a heating process. This way, you will see. Okay, pasteurizing, you have both heating and cooling. So that's why I didn't put that here. Yeah. So you can see The heat application, the same way. So boiled, or anyway, the hot food, okay, hot food, too hot to eat. So you may notice that in some food outlets, instead of real cooking, they do high temperature. They subject the products to very high temperature so that all the bacteria, whatever, destroyed, and at the same time, the goodness also destroyed. So that is not really good, but it's okay for the business because no complaints. Yeah. So hot food, too hot to eat. Yeah. Okay. Yeah. So you can see that kind of application. So now it is very important to note that Q loss. Okay. This is not possible to zero. Now I'm talking about this. Q loss not possible to zero. So let me duplicate this. Let me duplicate this slide. I'll make this quite small. Is it too small? Let's say this is 20. So this is our point, efficient use. This is the efficiency term. Okay, this is the efficiency term. Very interesting. So group this. Yes. Q loss not possible to be zero means there is a thermodynamics law related to this. Related to the second law of thermodynamics. Later I will explain this. Related to second law of thermodynamics. This is related to second law of thermodynamics. QL not possible to be zero. Related to the second law of thermodynamics. That is very important. So Q loss cannot be totally zero, but can be minimized. So minimizing Q loss is something very important when it comes to efficient use. Means try to make use of the heat in best possible manner so that only the needed heat for the process is being produced with minimal heat loss. You cannot say no heat loss. That is not possible. Okay? That is not possible. Okay? Efficient use. So this is general. So let's say if this is a car engine or engine, if this is an engine, of a car. If this is an engine of a car. It is very interesting and little bit new to food and IM students. Engine of a car. Okay. Efficient use. Let's say example is engine. Example is an engine. You may be laughing at this. Example is an engine. So from the petrol sparking, you are really receiving power to the engine. Okay. Sparking or from compression, somehow ignitions, you are receiving the engine receives the power, not you. Engine receives the power, and now this energy turn into work, W net or W, okay? Now it is W, that is what important. Same like the hot food, okay? Now this is Camus. Okay, Camus. Yeah. So W net is Qn minus Qw, because what engine does is convert energy in the petrol. You burn energy in the petrol inside the engine cylinders, and you use that heat to do some work. So that is what we call W use or W net. Okay, both okay. W use is Q in minus Q plus car moves. Okay, car moves. Very interesting. Yeah. So Q loss not possible to be zero means for an engine. So this is the engine. Engine. For this engine, this is the heat loss, Q loss. So this is related to the second law, not possible to be zero, this Q loss for the engines. So there is a special name for this related to second law. We call this Kelvin-Planck statement. Kelvin-Planck. Kelvin dash Planck. Kelvin-Planck statement. Kelvin-Planck statement. It says it is not possible to transfer all the heat completely into work. That is the Kelvin-Planck statement. So you are using the engine mechanism. Your objective is to use the heat from burning fuel The total heat, if possible to convert, is good, but it will not happen. Okay, but it will not happen. Okay, so there is a loss. There is a loss. That's why we call this, it is not possible to convert heat fully into useful work. That is not possible. Okay, that is not possible. So we call this Kelvin-Planck state. Very nice. Hopefully you can get some exam quiz out of this discussion today. Okay. And the efficiency wordings again the same. Efficiency is Q net or Q useful instead of this. Even we can use W net or W useful by Q in for this case. Okay, W net by Q in. That's a vehicle efficiency. Okay, W net by Q in. Very interesting. So heat is denoted by Q here. So engine somehow receives heat and then produces work. So that's how heat and work are related. As you see in your first slide here. So if I copy this, copy, and paste. Even rice cooking, rice is undergoing a process. So the size becomes larger and it's become a little bit, how to say, different texture and all. So the boiling is a kind of work taken place because of heat. Molecules are moving and some water bubbles are coming, jumping out. And you can see even the noise when you boil water or even when you cook rice, you can hear the sound because of the vibrations, molecular movements and all. That is because of the excited molecules. There is a work done really because of heat. That's why. So in physics, cooking is something like work done within the food because of the heat input. Anyway, this heat is a kind of energy, thermal energy, so that you can see the relevance of heat work energy here. So we talk about the clean energy aspects a bit here. And the renewable energy later, I need to talk about this. Shale oils, we talk about this as well. So it's time 3:46. I have to stop right now. So you have some other classes as well. So any questions before stopping the class? Any question before stopping the class? Utala. Very good. But anyway, I just talk about the rice cooking, water boiling, but you are already doing even some daily. So nothing new. You are seeing the engines all the while since from your childhood. So nothing and nothing special here. You have basic understanding about heat. And of course, work done is something moving of objects, like even in cooking rice. Some work is being done. Moving a vehicle, work is being done. And some new knowledge about shale oil and related shale, the pricing wars and the collapsing of economies, the redefinition of the world energy markets. You can see all related. And anyway, when it comes to the petroleum, the issue is burning. So burning causes emissions, toxins, CO2, greenhouse, global warming, climate change and all. So one thing we can do is efficient use. So efficient use is the measure is on efficiency. And here we just see how this heat being received and how the energy is lost and what is the use of the net. the key views, that's all. So later we can see how to optimize this energy receiving and the energy using and the energy losses to minimize. So today is just how to say, just an exposure for you, but little bit equations here about the efficiency, because efficient use, you have to measure the efficiency. That's why we have to have the efficiency values. So let me stop the class then if you have no problems. So, any question? Yeah. So let me stop the class for management students. Don't worry, Putana, this looks a little bit maybe not to say strange but unfamiliar to you, but this is nothing. This is nothing. So this is something like expressing the wordings by using maths expressions. You can see some brackets, divisions, equal signs, and all. This is nothing much. Okay. Anyway, the maths can be used as a language. Yeah, it's a common language, maths. Maths is not always to solve and to analyze. Most of the time, it's being used as the language. So here some pictures, some modeling like things, some maths expressions. So here we have used mathematics as a language to represent the things in a better way. That's all, nothing much. So don't worry about this. Don't worry about this. That's all for today. It's almost reaching 4. So see you afterward. Not today anyway. Good luck then. Okay. Good luck to you. So let me stop the class now. Bye then. Yeah. Okay. Bye.